Hello and welcome to Business Analytics. This is Hari Rajagopalan, and in this lecture we're going to talk about static forecasts. So we finished descriptive analytics. We're almost towards the end of predictive analytics, and then we'll move on to prescriptive analytics. But right now you have looked at forecasting, and this is called adaptive forecasting. All the models you looked at is called adaptive forecasting, because we are constantly updating level, trend, and seasonality with new data based on the alpha, beta, and gamma smoothing factors. So if alpha is 10%, you're taking 10% of new data and updating level. If beta is 20%, you're taking 20% of new data and updating trend. Same thing with gamma, is updating seasonality. But now we are going to look at situations when you run the model and alpha, beta, and gamma come out to be 0. All three have to be 0. So even if one is not 0, then you're in an adaptive forecasting system. All right. So if all three are 0, then you're in a static forecast, which means all you have to do is calculate trend and seasonality at the start, and then you don't have to change it. So that's what we're going to look at in the next few lectures. So static forecasts, as I talked about, assumes level, trend, and seasonality do not change. Initial value stay constant. And so the different kinds of forecasts we're going to look at is we're going to look at linear trend models. This is only linear regression, only looks at trend. And then we're going to look at trend and seasonality with seasonality as a categorical variable. So that we're going to do in this lecture. And then the next lecture, we're going to look at how we're going to calculate seasonal indices, calculate and optimize them. Then we're going to talk about how are we going to deseasonalize data before using linear regression and then calculating the seasonal indices, right? And then finally, we'll talk about nonlinear regression for data which is nonlinear. Now, these two will be a second lecture. This will be a third lecture. And then finally, we will look at how we are going to use static forecast as an initialization for the Winterhalter method. So that'll be the very last lecture for your time series analysis. So let's continue with the same company, Watercraft Models, right? And we have quarterly sales data. We have 4 years of data. We want to figure out what 2017 is going to be like. So this is the actual sales, and we have looked at this graph multiple times. So let's talk about the linear regression model. Here, time is the x-axis or independent variable, and the actual demand is y, or dependent variable, or the predicted value. So we're going to use data analysis regression, and I'm going to show you how to do this in Excel. And you end up with intercept, which is the level, and slope, which is the trend. You can also use a formula called trend in Excel. And trend allows you to select all the known y's, all the known x's, and then select the new x, and then we'll talk about how to use this. So I'm going to teach you how to do both, okay? So let's go and look at Excel. But before we look at Excel, let me just show you how the sheet is going to be set up. This here is the linear trend using the trend function. So we're going to say trend. We're going to select the actual sales and all the ones from time period 1 to 20, this whole actual sales. Then you're going to select time period 1 to 20. And then you're going to select actual sales for a specific time period. So in this case, we select 684.2, which is D3. And then we're going to put constant as true, which doesn't force the intercept to be 0. And it'll actually calculate the regression value for you. This here is based on the regression model we are generating, right? And the regression model, which we use data analysis regression, and we end up with the forecast is level plus trend times time period. And here is the 95% confidence interval. So remember, when you do 95% confidence interval, the lower control limit, the probability here will be 0 to 5, 2.5%. Basically, you take 100% minus 95%, that's 5%, and this you divide it by 2 to get 2.5%. And here, you're going to add that 2.5% to 95% to give you 97.5%. Okay, so let's go to Excel and see how this is done. Okay, so when we have a straightforward linear regression model, these quarters are not going to help because we're not assuming any seasonality. So let's make them disappear. All right, and let's kind of right now makes these disappear. So here's the data you have. You have time period and you have actual sales. All right, and you really are, you need to calculate mean squared error, RMSE, MAD, MAPE as usual. There's no difference there. And you really want to do a regression equation. So the first thing I'm going to look at is your trend, right? And so let's look at how this trend function operates. So the known y's, and here let's go ahead and look at this. The known y's, look at the blue color, which is your actual sales, right? This is your y, and the known x's is the entire time period. And this C3 here gives you the actual demand. And as you go down further, it'll be the same formula here. Let's go ahead. You can copy this formula, and it's the very same formula right up to this point. You'll notice, however, while your new x's are 21, 22, 23, your known y's and known x's stop right here. Okay? So make sure that's there. You can leave the constant blank. So let me talk a little bit about what the constant is. The constant is true, or you can omit it. But if you want to set it to 0, the constant is false. And we're not going to look at constant at 0. We're just going to focus on getting the constant. Now we're going to look at another way of doing this. This gives you an easy linear trend, gives you the formula, but it doesn't tell you what the level and trend values are, right? It just gives you this data. So to get the level and trend values, you can go to data analysis. And remember, when you did this regression, you know how to get data analysis. You go here, your input Y is your sales, your X is your time period, and you have labels, you have confidence level, you can run it, right? For time series, when we are assuming that your time period is dependent, you don't have to worry about the p-value, right? We are assuming this will affect this, okay? So here your R squared comes to about 87%, and you're looking at your coefficient and level and trend, and that's what you copy here. So what are we saying here? We are saying sales is about $375 before 2001, and for every quarter it increases by 92.63. And so once we get that, you can now put these in the formula, right? And you get your forecast. This is your forecast, and you'll notice your forecast is one big straight line. Why? Because it's a linear regression. Now remember, every forecast must have confidence intervals, and so you're going to build your 95% confidence interval, which is your forecast plus 1.25 multiplied by norm.s.inv, right? If you're going to use 95%, it's 0.025. If you're going to use 99%, it's 100% minus 99% divided by 2, which is 0.005, right? And the upper level is you add that to whatever the value is to get your upper level confidence interval. And that way you get your confidence interval here, right? And you can see the data is well within that confidence interval except right at the end where it kind of goes over the confidence interval. So your level and trend is there. Here's your mean squared error. So you're able to get everything here. This is your linear regression. However, this linear regression does not take into account seasonality. So let's look at the next thing. How do we use linear regression and also adapt to the seasonality we have? Okay, well, let's go back to PowerPoint there. So we did a linear trend model, but how are we going to get the seasonality, these up and down motions? How are we going to track that? with just linear regression? And the answer to that is, if you use these 4 quarters as categorical variables, as 3 categorical variables, we would then be able to trap the seasonality here. So let's go ahead and look at how we're going to do that. Linear regression with categorical variables, you've already done that. So remember, we convert the seasons to category variables, and remember the rule was to create number of categories minus 1. So if you're looking at monthly data, you have to create 11 binary variables. So the default category contains all 3 zeros, and then you have 1 0 0, 0 1 0, and 0 0 1. So we have 3 binary variables. Then we can use data analysis regression or use the trend function, and I'm going to show you how to do both. So here is the time period 1 to 20, and you can see quarters here. We have quarter 1 is the first. If it's 1, then it's first quarter. If it's 2, then it's the second binary variable, and if it's 3, a third binary variable, which leaves the 4th quarter as all 3 zeros as the default value. All right, and now we have intercept, slope. So this is the level, this is trend, and then you have values for each quarter. So let's go ahead and just quickly take a look. Here are the X values. So the trend model will actually use actual sales as the known Y, and the known X's is this entire thing, including the quarters. And then you essentially do the new X is this slot here. Okay, the regression model will actually give you level plus trend. Level is the intercept, trend is the period, level plus trend, quarter 1 plus binary variable. So you're going to look at the binary values. If it's 1, you use the values, and if it's 0, it doesn't. And of course, you have the 95% confidence interval. And looking at the answers, you can see that the intercept, the level, is about $559, and then for every time period, it increases by $90. However, the first quarter is about $86 less than the 4th quarter. The second quarter is about $431 less. You can see the real dip in the second. And the third one is $130 less than the 4th quarter. So remember, all these values are in comparison to the 4th quarter. So if all of these binary variables are 0, the level plus trend will give you the 4th quarter value. Okay, everybody with me so far? So let's go ahead and go over to Excel. But before that, let's take a look at the chart. And you can see here is your regression model. You can see it's up and down instead of straight. And here's the upper control, and here is the actual sales. So the regression model is much, much closer to the actual sales, and it actually follows the same patterns. It does seem to, here it's underestimating, here there is some overestimation, but overall it's actually being able to track the up and down motion here. So let's move on to Excel and take a look at it. Okay, so you see here we have, these are the values which first come, and then we are inserting 3 binary variables. Now remember, you've got to look at the number of seasons. If it's monthly data, you have to put 1 to 11, right? If it is 2 months data, then there are 6 values, and then you got to put 1 to 5, and so on. Okay, how you choose the default is completely up to you, and your regression will be different depending upon, let's say some of you decide 2, 3, and 4, and you're going to compare everything to time period 1, I mean, that is the season 1, then you're going to get a different set of regression values. Okay, so you can see here, let's go over the trend model, and here we go. We have G3 to G22, and then C3 to F22 as your axis, and then C3 to F3 kind of goes through, and that's your complete trend. And you can extend that all the way up to this here. So you can get your trend, or you build a regression model using data analysis tool pack, regression. Your Y range is your actual sales, right? Here is your actual sales, your X values, starting from time period. Don't select quarter, starting from time period is this, and you run everything and you get, make sure you format it nicely, and here you get your intercept slope. This is your level, right? This is your level, and this is your trend, and here are your seasonal factors for 1, 2, and 3. Okay, there is no optimization here, and this is the answer you get. So that's pretty much your how you create forecast linear regression with categorical variables to create your static forecast. So with this, we finished. These are the simple models. Now we're going to look at more complex regression models. So the next one is linear regression, where you have seasonal indices that are calculated and optimized. That we're going to do that. And then finally, we're going to talk about deseasonalizing data before using linear regression and calculating the seasonal indices. And then we'll move on to nonlinear regression, for which data is nonlinear. And once we finish these, we'll look at how we can use this model as an initialization tool for the winter halt method. All right, so quite a good ways to go, but hang in there and we'll get this done.